Welcome to this presentation in the series which is discussing solutions to some problems from STEP papers. Here is a page of acknowledgements with links to where you can find out about STEP papers, MicroRigs, which is a lot of resources about STEP, and the Khan Academy, which is the inspiration for this style of presentation. This problem we're looking at is question 9 in paper 1 2001. A ship, it's a trig problem. A ship sails at 20 kilometers an hour in a straight line. I've drawn a diagram here. Here's the straight line from A and B and beyond to C. That's the straight line which is at its closest 1 kilometer, put in the 1 here, that's 1 kilometer from a port P. P is the port. A tugboat leaves the port, maximum speed 12 kilometers an hour, and intercepts the ship, leaving as late as possible. How far does the tugboat travel? So think about this a little bit, and suppose we'll call this angle theta here. And the thing to understand first is whatever the angle theta is, let me change colour a little bit to see. So it could be very narrow angle here, which is only going to meet way up over here. That's possible, provided that the ship started far enough back. The ship goes faster, so it has to, the PC is quite long, so we'd have to start a long way back. You'd have to start very early in order to make that intersection. You could even head off in this direction and make an intersection here, and that would be okay as long as the ship was even further back when you started out. And what they're asking you for is to find out, well, how far back could it be? What's the minimum farness back it could be? You still make the intersection. That's another way of saying that you want the distance AX, which I'm going to call Y here, to be as small as possible and for you still to make the intersection. What you're asked for, by the way, is how far does the tug travel. So that's the distance PB. Let's call that X, because X is in the end what I want to find out. So if you imagine the angle theta varying, going right the way around from here, right round to there, from north right through to 180 degrees, then the distance Y here starts off very big, gets smaller to some minimum, and then gets bigger again, and we have to find out what the minimum value is. So let's just do a little bit of work here to work out what the length of Bx is and what the length of x is in terms of theta. Eventually what I'm going to try and do is get y in terms of theta, and then differentiate y, find the stationary point, therefore find the value of theta for that stationary point, and then find x. That's the general strategy. So my alternate angle, that angle is theta as well, because that's parallel, the line that I drew there. And sine of theta is equal to the opposite over the adjacent, which is 1 over x, which gives quite a neat, simple thing, that x is 1 over sine theta. And tan of theta is going to be helpful as well. That's equal to 1 over b of x, which means that b of x is 1 over tan theta. Why am I doing that? Because I want to say that, let me go up over here, that AB, which is the distance that the ship travels while the tug is in motion, is going to be 20 over 12 times PB, which is the distance that the tug travels, which, by the way, is equal to 5 over 3, just simplifying. The fraction, and PB we said was x. And what's AB equal to? Well, AB is equal to y plus bx, which is the same as y plus 1 over tan theta. So 1 over tan y plus 1 over tan theta is equal to 5 over 3x, which is equal to 5 over 3 over sine theta. So y is equal to, I'll leave it as this form, 5 over 3 over sine theta minus tan theta, which is the same as cos theta over sine theta. Don't have to do it this way, but I'm just choosing to make this a single fraction, 5 over 3 minus cos theta over sine theta. Right, my strategy is to now, I've got y in terms of theta. Excellent. I want to differentiate y and then find the stationary point, and that's going to help me solve the problem. And I've got here a quotient. I want to differentiate a quotient, and d by d theta of something u over v. I need to remember a formula here, that u over v, the derivative of u over v is something over v squared, and it's minus uv, and it's v u dash. So it's v the derivative of u minus u the derivative of v all over v squared. So dy by d theta is equal to, now going over to here, it's going to be something over v squared. Well, v is sine theta, so it's something over sine squared theta. And now v u primed. V is sine theta. U primed, the differential at the top is 5 over 3 will just go away. Minus cos theta is going to give me sine theta. Now I've got minus u. Well, u is 5 over 3 minus cos theta, because that was the numerator of that, and I've got to multiply that by the derivative of v, the denominator. The derivative of sine theta is cos theta. So what is this? Will this simplify? Happily it will. Still got sine squared theta on the bottom. So this is sine squared. And now I've got minus cos theta. I'm doing the second term here. I'm going to have plus cos squared theta. Then I'm going to minus 5 over 3 times cos theta. Minus 5 over 3 cos theta, which is equal to 1 minus 5 over 3 cos theta over sine squared theta. Right, manipulation's working out reasonably well. This has to be equal to 0 for a stationary point, and that's going to be equal to 0. Let me just make a little bit more space here. That's going to be equal to 0 when 1 minus 5 over 3 cos theta is equal to 0. In other words, cos theta is equal to, must be 3 over 5. In order to cancel that and get that out. Now, what are we trying to find? We're trying to find x, and x is 1 over sine theta. Well, I've got cos theta. How can I get sine theta? Well, sine squared plus cos squared is equal to 1. I know cos squared theta is 3 over 5. So if I work this out, I'll find that sine theta is equal to 4 over 5. I might have noticed this a different way, by the way, of just thinking of a 3, 4, 5 triangle where perhaps theta is here, and I've got cosine 3 and 5, 3 over 5, so that one must be 4, and that means the sine is 4 over 5, and that means x is equal to 1 over, which is 1 over sine theta, is equal to 5 over 4 kilometers, is the value of the minimum. So that's the minimum distance that the tug has to travel in order to intercept the ship. It's not the minimum distance, I'm sorry, it's the distance it travels when it leaves as late as possible. So it leaves as late as possible in order to catch the ship. Okay, so that's the end of the presentation. Thank you very much if you've been listening.